Hello and welcome to my channel. My name is Loange, and in this video we're going to do this related rates problem. So we're given that a cylindrical tank filled with water has a height of 10 feet and a radius of 3 feet. Alright, it is drained such that the depth of the water is decreasing at the rate of 0.1 feet per second. Good. How fast is the water draining from the tank? Okay, so the first thing is to try to visualize what you're given. Okay, that is do a diagram. So I've already done mine. That's it. So maybe I can make it a little bit. Okay, so let's see what we're given. We're given that this cylindrical tank is filled with water and has a height of 10 feet, a radius of 3 feet. Okay, now it is drained such that the depth of the water is decreasing. So the level of the water every second it is decreasing by 0.1 foot. So what this means is that the rate at which the water level is decreasing, all right, in other words, as which the height of the water is dropping. So I'm going to use this to denote that the rate, of course, that is the h, the t, that's the rate, is given by 0.1 foot per second. But since it is reducing, we're going to put a negative right here. Okay, that's nice. Now the question is asking us how fast the water is draining from the tank. So you need to understand what that means. So since we're talking about water here, it is measured in volume. Okay, so how fast is the water draining from the tank? In other words, what is the rate at which the volume of the water will be changing? Okay, and you know it's going to be dropping, okay, because it is draining from the tank. Good, but this is the question. We don't know what this is. Okay, so let's see what we can do. So the first thing is to look for an equation that will relate these variables. And of course, it's just the volume of equation for the volume of a cylinder. So we know that the volume of a cylinder, we can calculate that using V equals to, is 3 times the volume of a cone. That will be pi r square h. Okay, good. So coming to our own situation, we notice that the volume of the water will be reducing because we talk about the height is reducing, so the volume will be reducing. In other words, the volume changes with time. So it depends on t. It is a function of t. Then we equate that to pi r. So pi is a constant. The radius. Now notice this is a cylindrical tank. The radius stays the same from this level to this level. The radius is the same. So the radius is also a constant. Pi r squared. Then h, the height of the water level. So the height is changing, okay, as the water is draining. So it depends on t. Good. So here we have only one variable which is a function of t. This r here is not a function of t. We don't worry about that, and it is even helpful because we know what the radius is, 3 feet all the time. All right, good. Okay, so let's see what we want to do. We want to find the v dt. So we just go ahead and differentiate this function with respect to time. So we say the derivative, let's differentiate that with respect to t of v of t. As we differentiate the left hand side, this is pi r squared. That's a constant, pi r squared. Okay, then we differentiate this right here with respect to time. So we say the derivative with respect to time of the height function. But this is given, that is the rate at which the height is changing is given as 0.1 feet per second. But since it is reducing, we put a minus, that's a negative to that. That means we're going to have, we're going to substitute some given constants. So r, the radius is said to be 3 feet. So I'm going to put 3 in place of r, and that has been squared. We square that. Then we multiply it by this right here is given as 0.1, but since it is reducing, we say minus 0.1. Okay, so you take note of that. Good. Okay, so that means this is the rate. So this is going to give us, we multiply this is 9 times 0.1, 0.9 with a negative sign. That's minus 0.9 pi. So this is the rate at which the water is draining from the tank. Okay, so yeah, that is the rate at which the water level or the volume of the water is reducing. In other words, the volume of the water is draining. So how fast? Oh, sorry, I didn't take note of the unit. Very important, the unit should be in volume per second. In other words, that will be, let me write it out, the volume. So since this is given and we're looking at the rate at which the volume changes, that will be 0.9 cubic foot. Okay, so let me say cubic, or let's say cubic feet per second. So you don't forget that. Okay, so you take note of the difference. This one was given in as this is the height, that is a level, so it was feet per second. So since this is volume, it will be cubic feet per second. All right, and that right there is it. Okay, you can multiply this to get an approximate value anyway. All right, thanks for watching, and we're going to continue with another example.